Good morning. It is my pleasure to welcome you to our keynote. I am joined in this presentation by Dr. Vivek Puri, and this year we'd like to present on as-built schedules, more specifically what we refer to as the algorithmic as-built. And without any further ado, a couple of short bios that you can peruse at your convenience. Let me give you a heads up. I know we got a lot of schedulers here. Your CPM schedule is but one out of many probable outcomes. Without a statistical analysis, it is not a reliable predictor of when your project will be completed or which activities are likely to control completion. So that's kind of strike one. It may give you what activities you do when, but it's not a good predictor when the project will be completed. In fact, as you know, 90% or so of all projects is still finished late. When you have a delay, you anticipate a delay, and you add it to your schedule, and let's say it falls on the critical path, equating the extension on your critical path on your finish date to a day per day delay on your completion of your project is doubling down on a flawed premise. So it's not a good predictor of completion, therefore cannot be a good predictor of impact on completion either. So unless quantifying delay impact is grounded on a statistical analysis, likely impact on likely completion, the only reliable option we have is to assess the as-built impact, which is why we are having this presentation. Here's a quote, an abstract from a paper presented in 2019. I have clumsily highlighted a couple of statements. The first one in yellow, the as-built critical path is one of the most important subjects. All right. So, of course, if we are post-completion on a project, that is the last critical path that you ever had. And then they talk about this idea of catching the elusive as-built critical path. So if you are a CPM forensic scheduler, you have a problem with what they refer to as the elusive critical path. Well, we want to dispel the notion that the critical path is nowhere to be found, actually. And as demonstrated, I did a presentation at the PMI Global Congress in 2010, and I share with the audience the fact that if you use GPM, it will reveal the as-built critical path. It will give you total flows. And so 14 years hence, I'm doing it again. Perhaps people will pick it up this time a little better than last time. And hopefully, people that are in the business of issuing forensic analysis guidance documents will consider adding it in the next editions. Here are, by the way, the three forensic scheduling guidance documents in the world, as best I know. On the left, I have what we refer to as RP29, a document issued by ASCE, preliminary version 2007. This edition is 2012, and actually they're revising as we speak. There is being revised. In the center, I have the ASCE Schedule Delay Analysis Guidance document. And last but not least, I have the Society of Construction Law Delay and Disruption Protocol that comes from the United Kingdom. Now, if you were a forensic scheduler and you did an analysis and you were testifying in an arbitration or litigation, be assured that you will be cross-examined on these documents, whether or not you've used them, whether you're consistent or you deviated. So clearly, most of us in the business have read these documents many times. Here's an 1,000-foot view. ASCE 6717 has 35 guidelines on prospective analysis. In other words, I am updating my schedule May 24. I have a delay. I anticipate a delay. I put it on the schedule. I am doing a prospective analysis in the future. Opposite to that, RP29 concerns itself with retrospective delay analyses, something after the fact. They have two sets of techniques, modeled and observational. The latter one is what I refer to as eyeballing analysis, but they support it. In contrast with these two, the SCL protocol is a little more comprehensive. They concern themselves with both prospective and retrospective analyses. Both RP29 and SCL and all practitioners agree that once we have as-built documentation at the end of the project, that's what we want to be using. That was a statement from RP29. Here are a couple of statements. In addition, if as-built documentation is available, now if you had a project, went on for 30 months or what have you, and you had 30 or 60 updates, your last update is what is known as the fully progressed update. Well, if you have that, you have as-built documentation. So that is almost like 100% the case on every project. Besides that, you probably have daily records, submittal logs, and so on and so forth. So you have evidence that supports your as-built fully progressed schedule. Now, the SCL protocol, I believe that they probably have a pretty fine-tuned view of how to do prospective and retrospective analyses. They have a statement that is an important one. If you are, let's say that your project completed in November 23, and we're doing an analysis in May 24. A delay happened on your project in June 22. What SCL says, you don't go back to the June 22 update, because the critical path that is evident in May 24 is the one in November 23, your last update. So they don't believe going back to updates to do any retrospective analysis. Huge difference from other guidance documents. Now, here's what RP29 acknowledges. It is impossible to accurately determine the as-built critical path based on total floats. CPM software does not give you total floats left of the data date. On your fully progressed update, there ain't a total float anywhere if you're using CPM software. According to RP29 authors, the best you can do is dust off all your updates one by one and see whether or not it changed, and is it stable, is it not? I find a paradox that you're scheduling a project and you're doing your updates. They're fully algorithmic, albeit right at the data date. And then when the project is over and you have an important matter with millions of dollars riding on the outcome, you're going to go manual, because CPM software is useless to you at that point. That's what we are, though, if you are a CPM forensic scheduler. And it's repeating when some well-noted forensic schedulers have said on a paper, I believe, again, 2019, their CPM software is of no help. You got to use a bunch of data, and you have to have a subjective opinion. If you can withstand for us on the stand on a subjective opinion, more power to you. I'd rather not be doing that. So we are in a predicament. If you are a CPM software forensic scheduler, you're in a quandary. Sourcing your fully progressed update, what I consider the genuine as-built scenario, is handicapped. No total flows, no critical path. That's a problem. CPM software has misled us into believing that actual dates override early and late days left of the data day. That's not true. I'm about to show you that in a little bit. But that's what, I mean, I believe that for a long, I believe that until we developed GPM. I thought that was true. So post-completion, if you have a fully progress schedule, a bunch of updates, with CPM software, US bill schedule, it's in an unfavorable position and less helpful to you as you updates. So you go back to updates. But as pointed out, ACL does not support that, neither do I. So finding the SBO critical path. And again, here's a statement from the 2010 PMI Global Congress paper. If you use GPM, which Mr. Mather, I'm sure, hopefully you had a chance to join his presentation before this one. You know, he talked about GPM and all the things that it does, the algorithms. How is it that the critical path left of the day-to-day went amiss? In 1966, IBM released PCA software that I consider a landmark CPM software. Fact of the matter, I cut my scheduling teeth on PCS. It was the 360 Model 30, not the 4040. So PCS introduced the concept of the day-to-day. And basically, the people that develop PCS, they said, you know what? Let's just keep the whole schedule together. Before PCS came on the scene, when we updated the schedule, let's say I had an 1,000 activity schedule from January through December. A month had gone by. I'm sitting on January 31st. I want to update the schedule. Before PCS, what did we do? We removed from the schedule the completed activities. And we call that the cutoff date because we cut off those activities literally off the schedule. So now we have, let's say, 150 activities. PCS said, you know, why do that? Why not just keep them in the schedule and we just call it a data date and we just actualize their early and late starts and, you know, and we just focus on the future. CPM was introduced in 57, or excuse me, 57 was developed and heavily used in construction, late 50s to the early 60s. And when I started my scheduling career in 1960, fall of 67, I've been at it for like, what, 55 years, I guess, 57 years doing this in one form or another. That's, you know, we were not really using CPM retrospectively. It was all prospectively. Just to document that, in 1965, Jim O'Brien, one of the most iconic figures in scheduling, published his first edition, CPM in Construction Management, nary a mention of forensic CPM use. In 1969, he released a scheduling handbook, and he talks about he wanted to make sure that he had full coverage of scheduling using critical path. Still no mention. 1971, he released the second edition of his book. Nothing on forensic CPM. In 1976, Jim actually released another book. If I could get it right, Construction Delay, Responsibilities, Risks, and Litigation. And voila, he talks about 3 retrospective analyses using CPM forensically. He talks about the as planned, impacted as planned, should have been baseline. So basically, from 57 to 76, almost 20 years, we were not really using CPM retrospectively. So when the IBM people developed PCS, they sort of figure, well, why bother with left of the data date? All right, so that was kind of the genesis, how that came about. Now, because we want to know what the aspect critical path is, forensic schedulers have found workarounds, ways to find it. Okay, for instance, RP29 talks about, look, if you had a 2000 activity schedule, the project has been completed, fully progressed, you have actual durations, right? You have actual logic. Well, I can just take those actual durations, input them into CPM software. I can fix the logic, we're out of sequence, input the logic, and push F9 or whatever. What did you get? You're going to get early start dates for the activities. You're going to get early finish dates, late dates, total flows. Those are exactly the algorithmic total floats for you fully progressed update that's been simulated as a pseudo, as planned. That beats the heck out of some sort of a manual comparison of updates, trying to figure out what was the critical path, because it gives you the actual mathematical critical path and all the total floats. So in a sense, that schedule can be used forensically, except if you are using CPM software, you got a problem. All activities are on early start dates. You can't do any kind of delay extraction, any schedule collapse protocol with activities on early days. You have to shove them back to actual dates. And RP29 talks about, well, you can put a driving lag on every link and every logic tie, and then you force activities to the actual start dates. Now, if you had a 5,000 activity schedule, 12,000 or so logic ties, well, that, unless you kind of write a little code to do that, that's pretty laborious. It'll take a lot of time. Maybe less time than inferring things from a bunch of schedule stuff. But I'm about to show you that we can apply the forward pass and the backward pass left of the data date, just as we do right of the data date. P6 realized this a while back. I think it's at least about 10 years ago. And that link on the second paragraph, if you click on it sometime, we describe how that was done. However, when P6 was released with total flows left of the data day and late days, schedules were bunkers. They thought P6 had gone rogue, and they were so vociferous in their opposition that P6 kind of backed down a little bit and got rid of total floats, and but it gave you late dates. But you're gonna have to hunt for that protocol. It's not readily apparent, but it's there. There's an error in their calculation, though, so I'm warning you to that effect. Here's a very simple example. I have a update here, 2 critical path activities in red, 5 activities otherwise. Let's look at activity B. Now, activity B, D, E, and F are left of the data date. They're all completed, all right? So activity B has been finished. Notice that it was actually started on May 11th and actually finished on June 10th, all right? Those are the actual dates. However, we being schedulers, we know that it could have been started on May 1st, but it wasn't. Management decided to pre-consume some total float, 10 days in fact, and started on May 11th. B took 31 days and it completed on June 10th. B could have taken longer without delaying the project, 20 days longer, in fact, before pushing activity C. That total flow we call unused total flow. So, because activity C has a late start of July 1st, then we know that the late finish for B would be June 30th. So there you go. We have actual dates, early dates, and late dates. And in this case, I am pointing out that if total flows was used before the start date, we refer to that as pre-consumed total float and then unused. I'll leave it up to you following this presentation to go ahead and continue on with all the activities and prove to yourself that, geez, that is true. That is correct. How do we solve the CPM handicap with GPM? GPM calculates not just early dates and late dates and total float left of the data date, but also actually pre-consumed and unused total float for actualized activities and the evolving Asbury critical path. And as you know, your critical path may change from time to time. Just to give you a simple example, let's say I have a schedule for a project and I have a building A and a building B. And the critical path runs through building A, all right? And the critical path, if you were using GPM software, would also continue left of the data date in building A. Let's say some months down the road, you had a delay, a resequencing, what have you, and the critical path switched to building B. Be assured that the critical path left of the data date would also switch to building B, because the critical path must be a continuous chain from start to finish. So the critical path is evolving as to durations as well as to the work that is included on the critical path. Here are some literature that'd be worthwhile to review sometime. By the way, I have an extensive reference list at the end for those of you that would like to dive in a little more. On the left, I have the milestone paper from Kelly Ann Walker, who invented CPM, 1959. If you haven't read it, it's a lot of fun. Rightmost, I have the original paper in GPM. And second from the left, I have the PMI Global Congress, where I talked about forensic float or total floats left of the data date and so forth. Now, let me assure you that if you take a schedule and you process it using classic CPM algorithms and classic GPM algorithms, you're going to get exactly the same results. Both CPM and GPM are linear programming solutions to an activity logic flow network, which is what we use, of course, in our schedules. CPM is the primal solution. GPM is the dual solution. So you're going to get the same answer. But there's an important difference between the CPM and the GPM algorithms. As you well know, if you want to schedule an activity between early and late starts because of result leveling, just pacing the work, what have you, a voluntary constraint, you have to use a constraint date. When you apply a constraint date to an activity no early than, that becomes the early date. So you've lost the total float between the true early date and your constraint date. GPM, you can use a constraint if you want, like a contractual date, but if it's voluntary, because of result leveling, what have you, you can just use a planned date. The planned date lands right on the constraint date otherwise, but it preserves the preceding total float and knows the early start date. So GPM does not reduce total float when you move activities around. CPM does. And if you have a bunch of constraint dates, obviously off the critical path, at some point in time, you've disrupted the chain of activities. It's kind of hard to do a what-if analysis with a bunch of constraint dates. So GPM planned dates, which I'm sure Mr. Mather talked about, do not replace the algorithmic early start dates. The preceding float, right at the data date, pre-consumed float left of the data date, we call drift. The unused float or following float, we call float. The interesting thing is that no matter where you slide an activity between early and late start dates, drift plus float always equals total float. Here's an example of a GPM update. I'm pointing out 3 figures underneath each one of these bars: drift, float, and total float. Let's take a look at build and permit down here, 4th grid from the bottom. You notice that management decided to pre-consume 5 days of total float before it was started. The file for the permit, December 10th. It took 60 days. They got a permit on February 7th. It could have taken longer without delaying the project. It didn't. So the 5 days is the as-built drift, and the 12 days is the as-built float. Had they started build and permit 1 day earlier, the drift would have been 4 days. And if it would have taken the same duration, then the flow would have been 13 days. So they always add up to the same. But that happens both left and right of the data date. So now we are sort of winding down now, getting ready for Dr. Big's demonstrative. The algorithmic as-built schedule. What is this? It's the fully progress GPM update. Data date on the as-built completion date. Again, what I consider the genuine as-built scenario, with, of course, your actual dates, which if you're going to use it forensically, you want to validate, at least for critical activities and near critical activities, which really what matters. And it has also algorithmic as-built drifts, floats, total floats, gaps, and your early days, late days, therefore, the critical path, the whole shebang. Now, the thing about a fully progressed update is that activities are locked on their actual dates. So I'm going to escape from here and go into I have a NetPoint demonstrative. Hopefully I'm sharing my screen. And let me extend this a little bit. Okay, so let us suppose that I had this update on CPM software, but I imported it into NetPoint. Now, these activities are all on the actual days. If I try to move that activity, it's not going to go anywhere. So even though it's algorithmic, it's not suitable for delay analysis. If you want to remove delays from this schedule, there are a few delays that have highlights, excusable delays, compensable, inexcusable, what have you. You're going to have to destatus the schedule. Now, on CPM software, you can look it up online. How do I destatus CPM update? You'll get like a 7 or 9 step protocol. It's it takes a little work. It can be done. And GPM though, it's just fascinating how easy it is. All you got to do is you just right click on the data date. You reset the project to the project start date. Bingo. This schedule now, if I want to take that activity, move it, it's going to move. All right. So if I want to reduce the duration, the schedule is going to come back. Some people refer to as collapse. The end date is going to shorten. It's going to be earlier. The critical path is going to shorten, right? So now the thing about this schedule, though, if I was to look at MATS right here, BE, this activity here, you notice that I got 7 days of as-built drift, and it comes from this gap right here. Pre-consumed total float, minus 17 days of as-built float, and minus 10 days of total float. So as long as you have as-built drift, total float is going to be less than float. I'll have to admit that most forensic schedulers will be more comfortable working with total float. So how do we do that? We basically eliminate the as-built drift by adding a drift delay. I help myself out by having an activity here And I'm gonna click on it, and I'm gonna call it. We should get this right. Or close enough anyhow. Drift delay. All right. By the way, I'm doing this manually, but Dr. Big will show you, this is automated on GPM software. You can actually do one by one. You can do them all at once, what have you. So how do I get rid of the S-bill drift? I'm going to click on this activity here, click on the drift delay, and I'm going to connect them. Okay. So now I connected it. Now, again, as-built float minus 17 days, as-built total float minus 10 days. Watch what happens now when I take drift delay and I connect it to maths. Bingo, total float now is also minus 17, okay? Now, you don't have to do this, but I think it's probably recommended. That way, we work with total float. If you're presenting on an arbitration panel, you don't have to explain float. All right, so I'll go ahead and Dr. Big will show you, by the way, how he's automated this. I'll go back to the presentation, go to presentation mode. So basically, I right-clicked on the day-to-day. I chose reset the project start. Activities, they do not snap to the early dates. They stay right where they are. Why? Because actual dates and GPM are like plan dates, like actual plan dates. So, nothing happens. Now, if there's a delay on the record that is not on the schedule, you would have to, bring it in. You would have to take it out of durations, out of drift, but you cannot change actual start dates. That you cannot change. Those must remain the same. In the presentation deck, I have slides with what I just did myself. All right. So to more or less conclude, what are the features Algorithmic has built? No, I don't need driving lags. I have as-built drift, as-built gaps, and so on and so forth. All right. At this point, let me turn it over to Dr. Vivek.
Thank you, Dr. Gee. Let me share my screen and start the demo. Okay. Good morning, everyone. I'll walk you through a simple demo of the approach Dr. Gee just discussed and how our tools can help automate this entire process to aid in forensic analysis when delays occur in projects. What I'm going to demo is more of a prototype at this point and not a finished product. It's not available in any release yet, but it is something that we would eventually include in our tools. In this demo, I'm analyzing a schedule, and the analysis is being done towards the end of the project. And we want to assess how much delay can be attributed to compensable and excusable delays. This is a summarized project schedule with about 50 tasks here so that I can display them on the screen clearly. But if you have a detailed project, you can summarize it using Project Summit, our other innovative tool. And if you're interested in seeing how, please do attend the session right after this one. So in this schedule, we included certain delays which occurred as the project progressed. The schedule is completely actualized, and we do see that it finished 17 days past the contractual finish date, which is represented by this benchmark towards the bottom right of the schedule. The delays in the schedule are displayed using these orange texts, and some of them, like access hold over here, field order, change order, bad soil, these were compensable delays. There were certain rain delays over here too, which affected certain paths. And then there were other pink delays, which were attributable to the contractor or were inexcusable. So to begin the analysis, I will bring this window into view. This is our tool. In this view, it is actually showing the out of sequence logic. I'm trying to, this prototype is kind of built to show you the exact steps and how individual steps, what individual steps kind of go in the process of analysis. But this entire process can eventually be automated so that by the click of a button, you can analyze the schedule and evaluate the impact for individual delays. So the first thing that Dr. Gee said was part of it, that yeah, you want to correct for any out of sequence logic so that the schedule behaves or currently represents the behavior that was seen on the project. And so in this particular project, in this particular schedule, I only see 3 out of sequence logic, which are all tied to this contractual finish benchmark and thus really not affecting the project itself. We corrected for most of the out of sequence logic in this pre-presentation to make it easier on us and easier for the audience to look at. Then we look at some as-built gaps, which Dr. Gee referred to in his presentation as drift delays. He represented this 7-day gap before MATS as something that is a drift delay. It's generating drift for MATS was delayed, its start was delayed by 7 days. And so it was a contractor decision and thus similar to an inexcusable delay. Again, with the press of a button, any or all of these could be converted to delays, just as Dr. Gee demonstrated. You don't have to do all of them. You can pick which ones you were interested in converting, or if others, other users might want them to all be converted for this case. In the interest of time, I'll skip that too, and kind of trying to get you faster into the analysis so that we can see the results. Then the last part of the steps is kind of identifying what delays actually are in the schedule. And over here in this view, we show you all the delays that are in the schedule. And each of these delays have been coded by the user as what type they are. So we have certain compensable delays, we have certain excusable delays, and then we have other inexcusable delays. And the analysis will basically involve removing compensable delays first, and only then go into inexcusable to kind of ascertain how much delay could be attributed to the contractor. Okay. So let's move to the most interesting part, and we can go step by step in this so that we can see what the how the schedule is being modified and how the analysis kind of progresses. So to begin the analysis, I just press the button and the system identifies the best delay to crash. And we can see on the right over here, it is crashing access hold, and it says it can crash it by 8 days. We know the delay on the project was a total of 17 days, but the system only decided to crash access hold by 8 days, and we'll see why. There is this other competing path, tie-in and test, which is preventing it from moving past. So at this point, if access hold has settled in, it was crashed by 8 days. If we further crash access hold, it will pull refurbish equipment, but tie-in and test will hold the forecasted completion date. So crashing access hold at this point does not pull the completion date for the project any earlier. So the analysis stops at that point, and yeah, we can continue on to see what the next step needs to be. And the system identifies field order and change order. These are change order and field order delays over here, and we can see why it picked those. It can crash field order alone. That will pull concrete walls, mechanical, electrical testing, and all the way past to refurbish equipment. But field order by itself does not have any impact on this other path. Same thing for change order. Change order could potentially pull this and the other path, but because of this link from concrete walls to mat delay, field order would have held it back. So the system sees that and it identifies that it needs to modify multiple delays together in order to actually pull the schedule earlier. And in this case, again, it identifies that both field order and change order happen to crash by 8 days too. So at this point, we have accounted for 16 days of delay. We can still see there is a -1 over here. There is a 1-day gap between forecasted completion and contractual finish. And so we need to still continue. And when I continue, the system says, okay, field order, change order could still have been crashed. But along with those, now this contractor delay re-review needs to be crashed by 1 day. So because we are also removing compensable delays, we are not accounting for that to be a contractor delay. So but we can reduce contractor delay at that point by 1 day. And at this point, our contractual finish date and forecast completion met. And so this analysis stops and says, okay, we have identified and corrected the delays. So overall, the system found that all of the delay in the schedule could have been accounted for by compensable delays, specifically access hold, field order, and change order. And there was no contractor delay that was needed to kind of account for it. And this entire analysis was done by a single click, essentially. You don't have to perform all these steps when the system comes out or when we actually have a commercial release for it. But yeah, it can still give you an idea of how you can modify and what gets modified in your schedule. Okay. And at this point, I will turn it back to Dr. Gee to finish off the keynote. And thank you everyone for attending. Okay.
Options here.
Give me a moment to get back on.
Looks like the camera's on. Okay, I think it's good. Oh, I think we're not sharing the screen yet. Good start.
You go on the. Alrighty. So following up, wonderful presentation, Dr. Vivek. By the way, we have a couple of projects that are post-completion and will be using the prototype, perhaps advancing it, and maybe next year, if completed, maybe we can share how that went. So just to wind up, the so-called elusive Asbury critical path is not really so. We've debunked that with GPM software, with the algorithm. So, I mean, at some point in time, we got to give that up. Dr. Vivek demonstrated how to reverse schedule prolongation using the GPM crashing algorithm. So we can actually now stop talking about collapsing schedules, but we can talk about late completion delay, attribution delay by delay, with full consideration of concurrency. If you go to RP29, they talk about step structure and global structure. They don't even consider concurrency because it's not algorithmic. If you haven't had a chance to catch up with GPM, I advise you to do so. And you can download our software like a free trial. And again, hopefully this guidance documents will start to consider including GPM forensic features in their next editions. A little quote from one of the 7 framers of our Constitution: facts are facts, and if you are post-completion, the best facts you have are your fully progressed update and the data evidence that supports it. And we'll swing into, and at this point in time, welcome some questions.
Yes, thank you, doctors. We did have a question come up, and we invite anyone with a question to write it in the chat. But it was asked, how does GPM's approach provide a more empirical path compared to CPM?
Well, it's actually not empirical, it's algorithmic, because GPM gives you total flows both right and left of the data date. There's nothing empirical about it. And the fact of the matter, because GPM uses planned dates instead of constrained dates, you don't disrupt total flows off the critical path. And it's easier to do with F analysis, which I believe is about to come on the heels of this presentation. Thank you.
Yes, thank you. Well, that completes our questions. Thank you for a great keynote presentation. Coming up at 11, we'll be enhancing stakeholder understanding of complex what-if analysis, and we will be looking forward to seeing you all there. Thanks again.